My name is Ilse Andersson still, and today is the second lecture of these database courses, and the first topic today will be PLSQL. So the contents of this lecture, first part will be like this. At first I will tell you a little bit about these PLSQL data types, then I will tell you about PLSQL structures, language constructions, and then there will be cursors, triggers, data input and output in PLSQL, and exception handling. And what is PLSQL? If we need some additional data processing in SQL, in these databases, then in Oracle Database Management System we can use this SQL extension, procedural extension, and it is called PLSQL language. I will remind you that these operators of SQL can be grouped into following groups. There are data definition commands, where we create, alter and drop data objects, for example, tables, sequences, views, and so on. There are data manipulation commands, where we manipulate the data, for example, with select, insert, update, and delete commands. And there are also control commands, for example, commit, rollback, save point. And regarding PLSQL, this language can use some of the data manipulation commands and some of the control commands, but it cannot create, alter, and drop these objects. And the first topic, PLSQL data types. PLSQL language uses mostly three groups of variable types. There are scalar types, composite types, and reference types. I will tell you a little about these types, but these are examples of all these types. For example, scalar data types were common in this SQL also. So these are float, integer, number, char, varchar, to, and so on. Basically, all the types we use for table field definitions, table field types, they were scalar data types. There are also composite data types. For example, table is a composite data type that consists of several columns, for example, several fields. There are also records and arrays. I will tell you in detail about this first composite data type. This is record, and array essentially is an array that allows to store us an array of data in one table column. For example, if we have some table, and this is column 1, and this is column 2. For example, if column 1 has the data type of number, then we can only store one number in each of the rows. For example, in the first row we can store 2, in the second 3, 5, 2, and so on. If we have the column 2 defined as this array type, I will not go into detail how this is done. If you want to know it, you can find it in materials. Then you can store several values of this array type. For example, if it's array of numbers, then we can store in this column 2, numbers 1 and 2, for example. This row may store, for example, 2, 3, 4. This may store only 1 number, and so on. So we can store several of these values in this column. And about reference types actually reference a data memory area. So we do not. So we just reference it and do not really store it in this place, but we reference it. I will tell about cursor data type, which is also called cursor variable. And usually when we use these data types, we have these scalar data types, which are number, char2, char date, etc. And they are already there in the Oracle. They are defined in the package standard. So we can just take them and use them. If we want to implement a composite data type to use some record, table, or array, we must first create this table, this type. We must first declare it, and only then we can use it for some purposes. We must first create the structure of the table, and only then we can insert data in the table, for example. And as we have already seen the table type, I will tell you more about this composite type, record type. And this is one of the composite data types that PLSQL allows to use. And there are following record types. There are user-defined records, and there are records that are based on a table. So I will tell about these two types later, but at first I will tell you in general how these records are created in PLSQL. At first we must declare this type of the record. For example, we say that there will be a record person, for example, this record person. And when a particular record is defined, its previously declared type is specified. And this one record type can have many record instances. For example, there is some record person. This may be called data type, but this is written I just wrote the name of this record person, but it must be declared further. But if we want to use this record person, for example, we can say that we have a record instance, person1, which is of the type person. And then we can have also person2 of type person, and so on. So this is a type, similarly to the number, char, char2, and so on. And this is an instance of this type. I'll show you how it looks like right now. So we can see how this declaration of record is actually written in a formal way. We write this type, then we assign this type name. For example, in this case, it would be type person is record, and then we define all the field names and all the field types. We can also assign some constraints or some these default values. If we wanted to have, for example, a type person with fields name and surname, we would have a record of something like this. Type person. Is record. And then it would be similar to the table definition. We have name, for example, what char2 10, and we can have surname. And these are the fields of this record. So this is a more elaborate example of this examples that I have written on the Python. There is ID, surname, name, gender, and citizenship. So, and I apologize, there should be person type, not human type, but generally this is an instance of this record, and we can write these values in this record by assigning its some value with this assignment operator. This is one way to fill these records. For example, we have this record 1, and we want for the particular record, record 1, have a surname that would be equal to A. can also declare these records, not by declaring them manually in this way, but using, for example, writing varchar2 and varchar2 number and so on, this type. But we can also use existing database table fields. And in this case, we specify the table field types, not write them ourselves. For example, if we have a stable student, there's a stable student, and it has 3 columns, num, sir, and name. Then the record could be declared in this way. We have record type 2, for example. We have also the student number, surname, and name in this record, but we declare not by writing, for example, here, varchar2 and so on, but we write students, point, and then this is a column, percentage sign, and type. So in this way, we can show that we want to assign this, we want this column, this particular field of the record to be the type of student stable, non-column type, and so on. So we can use this way. It could work, for example, if we are not sure what the type of the table field is, or if we do not want to search for this information in these tables. Also, we can use these tables to define not only specific fields in this record, but also the whole record. For example, we can write just this way. Record 3, students, this is a table, point, and row type. And it would mean the record would have the same type as the particular row of the table. It would have all these columns and all these types that the table has. So we can write the information in this record right from this table. And the types will be equal. So how do we write the information in these records when we use them? We can assign values in different ways. For example, we can write values manually by hand. We could, for example, use this point syntax, write the name of record instance, point, and particular field, and assign it a value. And we could do it by saving the data from a table. For example, we could do it this way. Select, we'll be using select statement and selecting this, for example, if we know that this record 2 has 3 columns, num, sir, name, number, surname, and name, and also the table students has such 3 columns, then we could select these values from table students into record instance, record 2, and in this case we would select only the row where this number is equal to 121. Why do we do this? Because if we wouldn't use this condition, then there probably would be several results from this query select from students. And every record instance can only contain, basically, is equal to 1 row of the table. So we could not write several rows into this one record. That is an important difference. So if we take a look at this graphically, so we have, for example, this is a table. It can have several rows. And the record can only have 1. So we can only take 1 row from the table and write it in this record. We can also assign a value of one record to other if both these records are of the same type. For example, we have defined 2 these record instances of the same record type, for example, record 1 and record 2, and then we can just assign data to record 2, for example, in this case from the table, and assign the record 1 the same value as the record 2 has. And it will be exactly the same, so we can also do it this way. But if we have different these record types, it will not be possible in this way. We will not be able to assign one record to the other. Even if we used two tables which contained exactly the same fields with exactly the same types, if we would have used the declarations of this table, for example, for each of these records, they would, even they are in reality equal, we would not be able to assign them one to the another. So we must always be sure that they are exactly the same type. Are there any questions about these records? We will be using them in these examples further. I hope if you do not understand something yet, then it will become clear later. No questions right now? Okay. Then I will continue with PLSQL structure. So the basic element of the PLSQL language is a block. And there are several parts of which these PLSQL blocks consist. So we have four main parts. It's declare, begin, exception, and end. In declare part, we declare all the variables, constants, types, and so on. Between the begin and the end is the main program logic, and after the exception part follows the handling of exceptions. As can be seen, these two, begin and end, are written in bold. It means that they are mandatory. We always must use these two keywords. We always must have begin, we always must have end. Sometimes we can make do with these two ones. We may have no variables, no types, no constants, and so on, and we may not want to handle any exceptions. But begin and end we must always have. And PLSQL these blocks can be divided in several types. For example, this first is anonymous blocks. They are dynamically created and executed only once. They have no name. We cannot call them later. We cannot reference them in other programs. Programs are procedures, functions, and packages that are stored in the database. They are always there. They have name, and we can reference them later. So, and also programs are included, not only procedures and functions, but also packages and triggers. So packages allow to store related objects in one place. So we can store several procedures, functions, data types, and so on together in one object. Triggers are also programs, but they are different from others, that they are always executed when a previously defined event takes place. For example, they are always executed when we insert data into some table, if this is a triggering event. So if we do call these procedures and functions when we need them, triggers are executed automatically. And first about anonymous blocks, they are not stored in a database, and so they don't have a name. And this is an example of very simple block, for example. We even do not have this declare part, we do not have an exception part, we only have begin and end. And we have one instruction, null. In this case, null is instruction that does nothing. So this anonymous block also does nothing. But every block must always have at least one instruction in this part, between begin and end. Otherwise, it won't work at all. So we always have at least one. As I mentioned, anonymous PLSQL blocks do not have names, and they are not stored in database. To store blocks in database, we use programs, and examples of programs are procedures, functions, packages, and triggers. And programs always have a name, and they can be called from other PL SQL blocks. And the first of these programs that we will take a look at is procedures. And we can see here what is the syntax of procedure definition. We can use create or replace procedure keywords. Then we define what will be the name of procedure. It must have one. Then there are parameters. These are values that we will use for execution of this procedure, and they may vary each time we call this procedure. For example, we have a procedure that wants to that needs to write some phrase that every time it is called. For example, write this phrase on the list. So we might have a procedure, create or replace let's call it writing, and in this case we would have one parameter. Text. Yeah. There will be parameters that will be called text in the context of this procedure. For example, text. Then we must define in, out, and in, out. I will tell you about this later. In this case, it would be in. And parameter type, it might be varchar2. And is. In this case, we wouldn't have any of these variables, constants, and so on. So this is empty. We just didn't write anything between here, and we will always have begin and end. And in this part, we will write this the writing of this text. If I'm remembering correctly, this might not be perfectly accurate, but the idea will be and what it means is that this line or something very, very similar will output, will write this text on the screen. For example, one time we may want to have a writing of one text, for example, we have some, just for example, it might be some abstract of some article. Other times this text might be, for example, this subject list or something like that. Every time it might be something different. What this procedure will do, it will, no matter what this text is that is given to this procedure, it will just write it out. If we had some other parameters, for example, for example, some numbers that might be that would have to be added, multiplied, or something like that. It would each time take these different numbers and make some actions with it. What is characteristic to procedures? That it does something in its body. It does not return a result in a conventional way. that it is with functions. I will tell you about this later, but it only does some actions, and the only way to return some results outside of this procedure is to use out or in-out parameters.
Excuse me.
Yes?
Why do you have what for two in brackets? And in an example, you have what for two in brackets. I'm very sure that this is automatic outside the bracket. In the second law, where you get the text in what for two within the brackets.
Here?
No, on the second law.
Here.
Yeah. They have the parameter that inside the brackets.
Just put varchar.
Varchar 2 is parameter type.
Yeah.
Varchar 22.
They have it in the brackets.
Yeah, good.
Okay, varchar 2. It should be in brackets.
But they
Well, we have parameter list here. These are these brackets. If we had more parameters, then there would be comma and next parameter, next, and only after all this list there will be the next, the end of the brackets. They must be put in these brackets always. So, and about these in and out parameters. So, what do they mean? In parameters in the program can only be on the right side of the expressions. In this case, this may be considered right side of the expression, but it means actually that they can only assign some value. They cannot be changed, they cannot be assigned a value, they can only assign. On the other hand, these out parameters can only be positioned in the left side of the expressions. So they are only, they can only be assigned a value. So it means that we actually do not give with these out parameters some information for the procedure, but we give the procedure a means to return some value with the help of these parameters. So they will change in this higher scope also, not only in this procedure scope. And if the type of these parameters is not defined, it is in type by default. So usually we can exclude this writing if we want just to define parameters that we use for assigning some values to the procedure, these variables or so on. And there is also in-out type, and as we can guess, it means that it can be both in the right side and the left side of the expressions. It means that they can assign a value and they can be assigned a value. So this is the third type of these in-out parameters. And if we want to use this procedure, we must call it. So this is only the definition. Just the fact that it is written and we store it in database doesn't mean we use it. So to use it, we must call the procedure in other block. So it will not be done in this procedure block usually, and it is done in the following way. So in this case, we would write in some other block this procedure's name, writing, and there will be actual values of parameters. So if here we define these formal values, formal parameters, they are only formal. We always use some variable or something like that to denote them in this procedure. Then when we are calling it, we want to execute the procedure with some real existing values. So, for example, this writing might be, in this case, for example, it might be something like this. But in this case, it is a text that is given to this procedure, but it must not always be a constant. So we can also give a variable to this procedure. For example, we might have written something, some value of some text in a variable x, and also call this procedure by giving this variable as a as an actual parameter. Of course, there must be some value assigned to this variable x. So, and I will show you an example. In this case, this is creation of procedure. This is a procedure that brings full name on the screen. We have two parameters, name and surname. Both are this structure two parameters. Then we have no variables, no constants. There's logic of procedure. And this procedure, what it does, it concatenates and outputs the text. And this is what it does. These are concatenation operators. And then we end this procedure. So what this means is we take the parameter, this name. We do not have to put it in this quote because it is a variable and it is already in this varchar2 form. These are concatenation operators that put these text parts together. This is just denotes a space between these, between name and surname. Otherwise, they would be written together. And there's again concatenation operator and surname. And so this procedure takes two parameters, name and surname, and prints them out. And this is the way we call this procedure in some other block. So, for example, we would call it by giving it some values, Jānis and Bēziņš in this case, and the result on the screen would be something like this. There would be name, space, and surname. There are two basic ways that we can give the procedure parameters. We can give it first by using positional notation. For example, we can just give it the first parameter z as the second parameter, then the sequence in which we have written these parameters in this declaration is important. This is the one way. We must know this sequence. The second way, we can use named notation. For example, we can denote this, we can write this parameter and assign this actual parameter to each of these formal parameters. And in this case, we can give these parameters to the procedure in any sequence we want. We can do it in this way, and we could also switch the surname. It would be first, and the name would be second. It would not matter. It would work in both ways. But if we would just exchange these two, then it would be considered that this Bēziņš is a name and Jānis is a surname. And if they have different types, not varchar2 both, then the procedure wouldn't work at all. So this is one thing that must be noted.
And if we will put only the name, for example?
It would also not work. We need both.
But it is not working if
it is not working.
is not specified.
Yes, we need all these parameters. Well, procedure cannot know if it will need, for example, mandatory this parameter. Some may be needed, some may not be needed, but it does not know. And usually, if these parameters are specified, then they are used in some way in this procedure. And the next, so default values of parameters also can be defined. In this case, so this is what we can, in some way, we can avoid this, what you asked, with these default values. But in this case, we write either in this way, we just assign it to the default value, or we can type it also this way with the keyword default. Usually, though, you will need these parameters specified also. So, if we do not have default values, we must always must write these actual parameters in procedure calls. So let's suppose we have created a procedure, but we want to change some things in it. The bad news is that if we want to change the text of procedure, we cannot alter it in the way we used to do with tables. We must first delete this procedure and then create it anew. And it can be done in one of two ways. So first we can just drop procedure with this statement and then create procedure with new text. So second, we can also use just create or replace procedure, and it is automatically deletes the old procedure and creates a new one. So these two ways are exactly the same. But the main point is that we cannot just change one part of this procedure. We must write it completely anew. So it would be advisable if you write these procedures that you write them down in case you need to change them. And also you will need to then to give us these procedure texts in these records anyway, so you should always, any experiments, you should just copy them, because they will not be so easily changed later. Other thing that is a little bit similar to these procedures is functions, but there are several differences. There are also blocks that do have a name, and they are stored in the database. And they are created with create or replace, but in this case, instead of procedure, we use this function keyboard. What are the differences? There are several properties that makes these functions different from procedures. First is most important is that function must always return a value. So if procedure could only return data with out and in-out parameters, then function has a specific keyword return that returns the result of the function and gives the control back to the program that called this function. And also, unlike the procedures, for the reasons that say to return a result, these functions can be called in SQL, not only in PL/SQL, contrary to the procedures. And they are considered expressions in PL/SQL. So we could not call the functions in this way. As they return result, we must assign this value to some other variable. I will show you how it looks later. So the syntax of function definition is actually pretty similar to this procedure definition. There's also create, might be used or replace, function name, there are parameters, in-out, in-out. What is the difference that we can see is that there is the return function value type. We must define what type will function return. It might be some simple type, for example, varchar2, number, or something like that, but it could also be some of these more complicated types, for example, a record. Then after this begin keyword, there is a logical function. We can do whatever we want in this function, but there is one condition, at least in one place of this body, there must be this keyword return and return some value. And x in this case must be the type of function value type. So it must be the same as function value type. So here is an example of function. For example, we have a function that has 3 parameters, guest surname, guest name, and some number. It returns a Boolean value. Boolean value means that it returns either true or false, one of two. Then there are in the declaration part some variables are defined. In this case, variable 1 is number, constant 1 is also a number. There is function variable. It will be used for the return result, and there is also variable 2 For example, which is this guest salary type. What are we doing in this function? At first, we select salary from the table guests into variable 2. So as we can see, the variable 2 has this table guests called the salary type. So the types of this salary and variable 2 are equal. And the condition is that the surname of the guest is equal to parameter 1 and the name of the guest is equal to parameter 2. And then we make a comparison. If this salary of the particular guest that we have acquired is more or equal to parameter 3, in this case we have also given it in this parameter list, then function variable is true, else function variable is false. And then after that we do return this function variable and end the function. How does this looking like? For example, we have this we have a table, we have given it parameters, for example, yields bērziņa, and the salary, this is the name, this is surname, and the salary would be, for example, 200. For example, these are parameters 1, 2, and 3. So, if we find in some table, in this table guests, a record where there is, for example, this Ilze Bērziņa, we acquire some salary 300. So in this case, this is the record we find this stable guest. Then we select the salary into variable 2. So there will be 300, variable 2 will be equal to 300. And then we compare this variable 2 with this parameter 3, which we have given 200. And in this case, we can see that Ilse basic salary of 300 is more than specified the salary, the parameter of 200. And it means that function variable is true, and this is the value this function returns. Is everything clear?
No, not really. What is it in the row of the program? Let's say select salary into variable 2. What's the word salary?
It is
Because
a column name.
It's given in the uppercase, and I thought it was kind of part of a
In
operator.
this case, there's also this
Yeah,
uppercase.
well, I can see that.
It actually doesn't matter, but in uppercase or lowercase, it means in this case this is just common name.
Mm-hmm.
It could be in lowercase, it could be first capital letter, anything.
Mm-hmm.
But this is just common name. It is not a keyword or something like that. It could be anything, in fact. And the constant in this case is only an example. It isn't really used anywhere. We could use it for some comparisons or something like that, but in this example it is not used. And so, the calling of the function, as I mentioned, it would not work in this way, so there needs to be a little bit more complicated. It is a little bit more complicated. And in this case, there is an example how we could call this function. For example, we have anonymous block. This is a block without a name, so we just use it for calling this function. We have some variable in this case, in declare part, which is Boolean result. This is the variable once the result of the function will be signed. It must be the same. This should be this. These are one. They should be in the opposite way. Sorry about that. And then we begin, and this is the result, and it equals to function 1. So, as we can see, this is a function, in this case is an expression, which is assigned to the variable result. We call the function, it returns the result true or false, and this result is assigned to the variable. Is that clear? Okay. So we could also do it a little bit more complicated way. This is also this result, which will be defined, but we also define some other of these variables. In this case, it is surname and name, and this type is taken from the table guests. So in this case, this is guest table surname type, this is guest table name type. And then we acquire the name, these variables, surname and name, from the table guests, where this guest identifier is equal to some number, for example. This must be a unique number, no more than one of these numbers should be in this table for this query to work. So, if we have several records in this table, we just take one and write them into the surname and name. And after that, we give this result, we give this function these variables, surname and name, as parameters, actual parameters. And for example, if this identifier would be equal to this 256 for the person named Krumich and Jans, then the values we would give to this function would be exactly the same as in this example. Otherwise, they will be different. And if these person names and surnames would change in time, each time we would call this query, it would return different results, and also function results might be different. If we want to store some related programs together, some related procedures, some related functions, and also data types, we can use packages. And every package consists of two components. There's a package header, or otherwise called package specification, and there is a package body. These are two separate parts that we must define when we use these packages. And at first we define this package specification. So we use create or replace package, package name, this is the name of this package, and then there are listed all the procedure call descriptions, function call descriptions, maybe some global variables are defined, types are defined, also exceptions and parsers. And then we just use this and package name. We do not specify very deep what will these procedures and functions do. We only tell them that in this package there will be such procedures and functions. So, in this case, we show, it can be seen that we use this procedure, for example, procedure 1, we define these parameters, but there is no procedure body. There is no logic of this procedure, only the header of these procedures and functions. There will also be 1, 2, 3, 4 procedures, as many as we need, also some functions or something like that. We can also define types and global variables in these packages that will be used in, that will be recognized in all of these procedures and functions. So if we use this, they can be used in these procedures and functions too. After we have created the header or specification, we can create the package body. And in this case, it is very similar, with the difference that we define that this is a package body we create, not just a package. And for each of these procedures and functions, we define this logic too. So, as we can see, we do not only have these parameter lists and then the next procedure. we also have this begin and end. So we will write all the logic in here. If we have created some functions or procedures in a package object, then we must also have a way to reference it. And in this case, the name of package and object must be specified together with parameters if they do exist using this point syntax. For example, if I have package with name package name and object with name object name, then we would have such syntax to reference this particular object. In this case, it will be procedure, because we have not assigned this value to any other variable. So in this case, this will be package, this will be procedure, and this will be the parameters we have specified for this procedures. And there is such thing that we can use several procedures and functions that have the same name. So several procedures could be called compute total sum or something like that, but they can only have one name if they have different input parameters. So this property allows to specify desirable input parameters when calling the program. For example, if we had some procedure sum with numbers as parameters, I will not write it in the right syntax right now, it's just like for the idea. And we call it sum with numbers. It might return the sum of numbers, for example, 1 plus 2 would equal 3. But we could also use some other procedure, which is also called sum. But in this case, it might be, for example, of order 2 types. And if we would call this procedure sum and give it parameters that are order 2 type, then depending on what we have written in this procedure, it might, for example, give us a text 1, 2, just a text. This, for example, or it might be connected with some symbol or something like that, whatever we have written. So it means we could also give, for example, 3 parameters for these 3 numbers and define a procedure for each of these cases. And depending on what parameters we would give the procedure, the result would be different and also more. About these PL/SQL language constructions. You have already seen some of those. This is one of the most popular constructions that PL/SQL and other procedural languages use. And we already saw it in one place, in one example. It is if then else. It is possible that during the execution of program, it may be necessary to execute a different program part depending on the result of some condition. And if this is the case, then we usually use this if then else condition. For example, as we could see previously, we might want to do different things if we have a salary larger than some parameter or salary smaller than some parameter. For example, we just do this comparison. And for example, if it is larger, it is true, we might do some actions that reduce the salary. If it is not true, for example, we could do that it remains. So the same salary. No, that's just an example. We could do anything, in fact, with these conditions. So an example of this if then else can be seen here. It is of course a construction that we use in this begin end block, but because it is a program logic, it is something that we want to do. And in this example, there are several conditions. First, we compare the pension. If pension is smaller than 100. If the pension is smaller than 100, then we assign the variable evaluation that it is very small pension. And that's it. We go after that right to the end if and do not look at all the other conditions at all. We just look at this one condition. If this condition is not true, so pension is not smaller than 100, then we might check if the pension is smaller than 150. In this case, if it is, it means actually that it is larger than 100 and smaller than 150. Otherwise, it wouldn't have gotten further than this comparison. Then pension is evaluated as small. If this is still not true, then we can compare pension smaller than 200. And in this case, we give it an evaluation of standard pension. As we can see, these are else if. It means that there is a meta condition that we compare. If we do use this keyword else, it means that in all other cases that are not one of these four, then in all the other cases, these actions in this part will be done. In this case, the pension will be evaluated as a large pension. So, in this case, all the cases will be considered, and we will have evaluated the pension as anything from very small to large pension. If we had excluded this keyword, there would be only possibilities of very small, and standard pension. But this else keyword is not mandatory. We can exclude it. We can also not use this else if statements. The only part that is mandatory that we must always use in these conditions is if, then, this one comparison, and there must always be this and if keyword. The other are optional. The only condition is that if we use this else, it must be the last of these. It cannot be before this else if, for example, anyone. And so we can make the program do what we want to depending on the truth of some conditions. The other very popular construction in programming languages is loops. With loops, we can repeat the same operators many times. So it is basically the essence of programming, the repetition of similar operations. When we are implementing loops, we must make sure that we avoid the infinite loops. This is one of the simple loop examples. In this case, this is loop. And if we just write this one operator between these two keywords, then the loop will never end. It will endlessly increase x by 1. In reality, of course, there will be end because memory will end and the place in memory will end. And there will be an error and the program will stop. But if we could theoretically run such loop, it would never end. So we must use some condition that ends this loop. In this case, in this loop, simple loop, we can use this exit or exit when condition. So we can just put in some place word exit, and to ensure it does not run in the first round iteration of loop, put it in some if operator. That would be most complicated way, but we can also just use this exit when condition, and in this case we can put it that loop x when x is larger than 200. So if x is 0 at the beginning, this loop will run 200 times, and 200 times some operations will be performed. There may be different, a little bit different of these operations performed if we have some if conditions and so on. There are other types of loops also. For example, there is such loop as while loop. Most of loops can be implemented in any of these ways, but there is a little bit different syntax. In this case, while loop is executed while some condition is true. For example, we write it like this: while x is less than 10, loop x is equal to x plus 1, and then end loop. So it will run until x exceeds the number of 9 actually. So when it reaches 10, this condition will not be true and the loop will terminate. And this expression x plus 1 in this example ensures that the infinite loop will be avoided. So there will be some time when this x will be for sure larger than 10. For loop is the loop that counts how many times the loop must be executed. And in every iteration, the value of variable counter will assume the concurrent iteration number. This is a variable. It must not be called counter. It may be any other name that is permissible in this PL/SQL. And here we denote this interval in which this loop will run. For example, in this case, it will run from number 1 to number 3. And in this case, we will insert 30 rows in table 1. And the values that we will insert in this table would be, in this case, it would be a counter, 1, 2, 3, 4, 5, 6, 7. And the second row will just contain a text row number. So there are 2 columns in this case in this table that are filled, and we write these row numbers, and we write the text row number. This is what we are doing with this for loop in this example. The next big topic is cursors. If we could see in this example, I hope it could be seen that PL/SQL can process the records, which I told you about in the beginning, but not the sets or tables which are very common in this SQL. To retrieve the data from database tables in the form of records, we use cursors. And there are 2 types of cursors: explicit cursors and implicit cursors. So, as we remember, the record was something, for example, with in this case it would be these 2 fields. This is an instance of the record. It can contain only 1 row of the table. We must have a way to write these to process a lot of values. For example, we might have a table also with field 1 and field 2, but we cannot write all these values in 1 record. And we might not even know how many records we will need. Cursors help us to process the data from these tables by writing them in records sequentially. This is not actually what cursors are, but I hope it will be visible when I show you some examples. So cursors contain some values from the table. There can be several of these values, and these values from these cursors can then be written in these records. First, I will tell you about these explicit cursors. They are the more complicated type of cursors. When you use implicit cursors, you actually mostly don't feel you are using them at all. They just perform almost all the actions automatically. But when we use explicit cursors, we must perform the following actions. So we must first declare the cursor, we must open it, retrieve the data from database to PLSQL structures, and then we must close this cursor. And the first action is declaration of the cursor. And what we do with cursor is actually that we, in the declaration part of this block, we write keyword cursor, there is a cursor name, is, and then we write some query that we want to store in this cursor. For example, if we had a table of students with fields, name, surname, and course, then we could use a cursor that selects, for example, only name and surname and only some rows of this table students. So we can actually perform almost any of these queries that we can use in this SQL and just store them as cursors, in the cursors. Similarly to the procedures and functions, cursors can have parameters. So in this case, after the cursor name, we would have this parameter declaration. They are done exactly the same way as in procedures and functions. We use this parameter name, and after that we also denote this type. And in this example, we select surname, name, and salary from table employees, where gender is not equal to woman, as in this case, but we choose this gender from the parameter. So we can, when we are calling this cursor, we can write if it has woman or man or maybe some other gender in this as this parameter. So if we wanted to then declare the cursors in this way without parameters, and we would have to use these cursors in the program body once with gender woman, the second with gender two, with gender man, we would have to declare two cursors. In this case, we have to declare only one. So this is what parameters are all about. After that, when we have declared the cursor, in the begin part, we just open this cursor. We just write this part, open cursor 1. And if we are using some parameters for this cursor, we open this cursor by denoting these parameters. In this case, it might be a woman. And there is a thing with cursors also. This cursor can store many values similarly to the table. It can only access one of the rows at the present moment. And this row is called a current row. For example, if we have cursor 1 is 2 fields, and there are rows 1, 2, 3, 4, there are 4 rows, we can only access one of the rows at the moment. While we are here, we cannot access the row 2, 3, or 4. We can only access the row, for example, 1. And to move through these rows, to process all the rows of the cursor, we use the command fetch. When we execute the command fetch, the current position of the row moves to the next row. For example, when we execute fetch, the position of the current row moves, in this example, to the row 2. And we can process the next row. So to use these cursors, we usually also use some loops to retrieve all these values that are stored in these cursors. In this example, we can see that we have opened the cursor and fetch cursor 1 into record 2. But in this case, this cursor one must contain exactly one row, or else it won't be possible to store it in record 2. If we have several rows in this cursor, then we can retrieve all records, for example, in this way. We have also opened this cursor, then we run a loop that fetches cursor into record 2 and exits when cursor 1 is not found. This is one of cursor attributes, and it shows that there are no more these records in this cursor anymore. So we cannot continue fetching these rows. And then when here we have acquired this cursor row into this record 2, we can do whatever we want with this row, what we need to be done. So as we can see, we cannot use, for example, these classical aggregation operations that we use in SQL. So we cannot process all these rows at the same time. Actually, we have to process them manually in this case. So for example, if we want to compute some sum, we have to compute this sum by ourselves. And cursor, actually these cursors have 4 attributes. First, you already saw, is not found, that new record is not found. There can also be a found attribute when there is a new record. So there is we have found a new record, so we can use it. This attribute detects if the cursor is open or closed. If it is open, then it is true. And there is also a row count that counts how many records the cursor contains. And it is of the type integer value. And the syntax to write these cursor attributes are like this. We write the cursor name, and then follows this percentage sign and attribute. After we have retrieved the data from the cursor, we will not be using it anymore. We can then close it, and we can also do it after this in this begin part, but before the end part. And we just write close cursor name, and then it will be closed. And there is an example of using a cursor. In this case, we have some employee record that is row type of the employee table. We have cursor, employee cursor, that is all the records from, there is missing one of these, the missing table, employee table, there should be all these, there is all the records where salary is larger than 10, and after that we start the begin part, open the cursor, then we start one of the loops. In this case it is a simple loop. We fetch this employee cursor into employee record, which we have defined at the beginning of this block, and write on the screen that employees that we have acquired first name and last name. And we exit when cursor is not found. Then we end the loop and close the cursor. And ASCII cursors, I already mentioned, are usually used for reading several rows from database table. They can be implemented by using a loop. There are several loop types that can be used. This is one way we can use that was already shown in the example, that loop exit when cursor name is not found, and loop. We can also use while loop, but in this case we will use this attribute cursor name found and continue while there is a cursor record in this cursor. And we can also use for loop when we define the variable in when we use this variable and just this syntax in cursor name and loop until this cursor no longer has any records. In this case, all the things are performed automatically. We do not have to open the cursor, we do not have retrieve and close this cursor. We also do not have to define this variable. It will be the type of this variable will be defined automatically. So this might be one of the easiest ways to perform cursor processing. An example of this cursor for loop is can also be found in materials if you have interest to look into it closer. Besides explicit cursors, there are also implicit cursors that are used for the operators insert, update, delete, and select into. These cursors do not need decoration, opening and closing, and all these actions are actually performed automatically. And implicit cursors are all defined in the begin program block. We do not need to write this declare block like explicit cursors, and the instruction contains the expression into, and the select instruction does not need opening, data retrieval, and closing. These implicit cursors also have attributes, but in this case there is not a cursor name. We have not assigned a cursor name, so we just use this keyword SQL. And if SQL is found, then if function retrieves the data successfully, it is true. Not found, if the data were not retrieved, not even one row. In this case, also the exception is raised. It is called no data found. And we can also retrieve the code of these rows of implicit cursors. And there is an example of the implicit cursor. We do not see a keyword cursor anywhere. It just is there. So select into record 1 from employees, where department ID is equal to 100. And in this case, if SQL is not found, then insert into result table. We just insert into other table some values that record 100, for example, was not found. So this is where we call this implicit cursor, and this is where we check if this cursor was successfully found, executed or not. Previously, all these cursors were static cursors, and each cursor had its own SQL operator. Even when they had parameters, SQL operator was the same. Instead of static cursors, the cursor variables also can be used. And they can be sequentially related to several of these SQL operators. And cursor variables can be very useful when the data to be retrieved is not previously known. And here we can see the example of cursor variable. In the red, there is main differences that we can see from these cursors that are not cursor variables. As we can see, we are defining cursor type, cursor variable type, by using this reference. We write this keyword is ref cursor, so it means that this will be not just a cursor, it will be a cursor variable. Then we define a cursor variable of this cursor variable type. We need to do this so we can reference some variable, not just some type, later in this program text. After that, we open the cursor variable, but the difference is that we do not just write open cursor variable because we do not yet know what the query will be that we will use, but we also write the whole query that we will use for this cursor variable. And then we just fetch, we can just fetch cursor variable in the record log, just like the U in the simple cursors. Also, all these attributes are the same, and we also close this cursor variables the same. So the main difference is, as we can see, we need to define this reference. We have to open the cursor and write the whole query. If we want to, then we can later open this cursor with different query. So we can retrieve different data from other table and still use the same variable. So this is the main difference that cursor variable has from these simple cursors. Are there any questions about cursors? Okay. I think I'll go into some. So, the next topic is triggers. These two or three last small topics will be more theoretical, as you do not have to implement no triggers in these practical works, but it is nevertheless useful to know what these triggers are and what they can do. And these questions can also be in the test, so you should know them anyway. So what are triggers? Database triggers are file SQL blocks with a specific structure. They are programs that execute when a previously specified database event takes place and all the specified conditions are true. So they execute automatically. When, for example, some row is added to table, when some rows in the table are deleted, some structures are deleted, objects deleted, anything that we have specified can be done with these triggers, almost anything. And the execution of the trigger is called the activation or firing. And there are many different events that can cause these triggers. These are some of the most popular. For example, a data manipulation operation is executed for some specific database object. Also, a data definition operation is executed in database. User logs on or off, some server error occurs, and many other events. And every trigger has three main components in its structure. It has triggering event, it has trigger condition, and it has trigger action. And this is an example of this definition of the trigger. We can create or replace trigger. There is trigger name, before or after triggering event, when it will take place. We want to execute before, for example, some rows are added or after that. We also must reference some, for example, this data table or other object that it will relate to. There may be also some trigger condition when it is executed. There may be also no conditions, and it may be for each of the row that is affected, or only once for all the statement. So it will be executed either several times or only one time. And there is also a trigger body where all this code, the logic is written. If we take a look at this example, in this case, when employees table is updated, so we change some values in this employees table, this trigger is fired, and there is this condition when new salary is greater than old salary. Only in this case, this trigger will run. So if the new salary will not be greater than old salary, the condition will not be met. But there is also this condition for each row, so this condition will be checked for each row that is updated in this employees table. And after that, we can write it very similarly to these procedures and functions. In this case, there is the declaration part where we declare this record 1, which is of the employees table row type, and we, in this case, write the record 1. We assume that this employees table has field notes, and we write that there has been an increase of salary for this particular employee. And after this, in this case, we only write it in this record, but later we can also modify this table to write this increase also in this employees table. So in this case, we can do some things automatically when these triggers are fired. Triggers can be divided into groups by 3 parameters. First, it is operator type that calls them. There is execution time, if they take place before or after the operator, and execution level. So I already mentioned that it is executed for each row or only once per statement. And the sequence of this trigger execution is the following. At first, we execute all the triggers that are before this statement that are executed only once for the whole statement. Then we execute all the row triggers for the statement that are before the statement. Then we execute all the statements after, all these row actions after this statement. And then we execute triggers that are after this statement and are executed only once per statement. So this is the sequence they are executed. Triggers can complement standard options of Oracle to ensure flexible database management system, and there are several common trigger applications. We can automatically generate new column values. We can avoid some incorrect transactions, perform complex safety authorizations, implement complicated business laws, maintain synchronous table copies, create some table access statistics, and many other things. But many things can also be achieved with the help of constraints that were explained in the first lecture. And the situations when the triggers are recommended, not constraints, are the following. When the reference integrity must be ensured, but these children parent tables are scattered in different parts of the database. When we need to enforce complicated business laws, they cannot be ensured with integrity constraints. And also, triggers are recommended when the integrity rule can be implemented with any of these following constraints. Not null, unique, primary key, foreign key, check, delete cascade, delete set null. So if we can't do it with these constraints, then we might try to do it with triggers. About data output in PL/SQL. As the PL/SQL was created mainly for the processing of the database data, not for data output, the input and output commands in this language are very few. In PL/SQL version 2, package DBMS output was included, and it also allows some information output. There are the package that is mainly used for data input and output in this PL/SQL, and there are two main operations that can be performed with this package DBMS output. The first is put, operation put. It writes the data in buffer so they can be later read and used. And the operator put can be executed with several different procedures. One is put. It simply writes this data, but there is no end of line indication. So if we use several puts, they will put all these data together and there will be no separation between them. We can use put line and there is end of line indication. So it means every data unit that we will put with this put line will be in a separate line. So we can separate them. And there's also just a new line. It inputs the end of line indications. And put line is equivalent to put and new line sequentially. So instead of put line, we could just use put and new line. We could see in some of the examples how the information is written on the screen with this put line command. So you can just check it back and take a look at these examples. And also on materials you can see these examples. And there is also operation get. Operation get reads the values from a buffer and returns them to procedure. And the execution of this operation get are performed with get line and get lines, depending whether we need one or more lines. And this is an example, for example, how we can write some information on this, some data on the screen. Sometimes when the PLSQL program is executed, there are some errors. In this case, the exceptions are raised. And there are two error types. There are compilation errors and execution errors. And exception handling can only handle these execution time errors. For example, compilation errors are errors that you, for example, see when you are trying to run some, create some table, and you see that something was wrong with that, there are errors, and this is compilation time errors. But execution time errors may occur, and they may not be shown in this compilation. For example, when Oracle compiles some procedure, it may not know that we will give it a parameter that makes it divide by 0. For example, in this case, there will be execution time error, but no compilation time error. And as I mentioned, exceptions are raised only for execution errors. And there are two types of exceptions. There are standard or predefined exceptions that are defined by Oracle. They already exist. And we can also define our own exceptions. These are called user-defined exceptions. There are some of the most common exceptions in Oracle. For example, zero divide division with 0, no connection with Oracle database, data are not found, some incorrect actions with cursor, arithmetic or conventional errors, operator select int returns more than one row, wrong username, password. There are also other exceptions. But if you want to create these user-defined exceptions, then you can take a look also in this materials. There is an example of how it is done and what is all the syntax. I think it might be time for me to end today. And at the end, there is a first part of practical work. Or second part, I don't really remember, but the idea is that there are several things that you have to do. First, you must create one anonymous block and one package which includes one function and one procedure, at least one. You can make more if you want. That satisfies all these following conditions. So at least one function procedure must have variables. You must use if then else construction. Also, you must use at least one loop and implement at least one explicit cursor. And also, you must demonstrate all these procedures and functions, what results they give. So there must be text of these procedures. There must be the texts, these programs, how you call them, how you have called them, and also you must demonstrate what results they have returned.
Connect the laptop to the charger. It's not. No, it's okay.
Any questions? I have translated my materials, but I'm not sure how to give them to you right now.
I think there is no hurry to give the material because all of you have to finish the first lab first and then continue with the second one. So probably the materials will be on the website of the course tomorrow or the day after tomorrow, and you should be fine with them then. Thanks. Okay. How long would you like the break to be? 10 minutes, 15? I think no more than 15. We should make a break. It's late evening. Okay, then 7:10, we'll start the second part. Thanks. Droši. Man jau gribās attaisīt pogas, laikam gaisā, bet tos, ka cilvēki mēģļos ar sēž. Es drīkstu?
Kāds nokrīt?
Kur? Enterprise architecture? Nē, es skatos, čekoju, tur nebija. Jā. Jā. Man bija.
Visi nolika, kas bija atnākuši. Tā nē, ja?
Man bija 4 atnākuši.
Man bija 3 tikai, diemžēl. Viens vienkārši izdomā. Nu tas. Visi iepriekšējā vakarā nokārto visu laboratorijas darbus, lai nāktu uz eksāmenu, un pēc tam uz eksāmenu neierodās. Redz, es esmu pārdomājis, ka būs grūti nolikt.
Nu, man 2 nenolika.
Tev 2 pat nenolikt, ja?
Varbūt par grūti, bet nē, man ir 2 tūri, 2 tūri.
Nē, man atkal viss ir diezgan vienā gabalā. Man ir no 5 līdz 8. Pēc studiju darba 10 testam 8, gan 9 beigās ielikt. Ja, man noteikti priekšā studiju darba skaitās iekšā eksāmenā. It kā man iznāca 8,4.
Nu, labi, man arī bija. Nu, man tur bija punkti. Vai man vienam pietrūka puspunkts, un otram pietrūka 0,2.
Līdz 4?
Nē, līdz 9.
Līdz 9.
Līdz 4 bija tik bezcerīgi, ka tur es nevarēju pievilkt.
Jūs pasniedzat visu, kas attiecas uz datubāzēm tikai vai plašākā lokā?
Godīgi, tad datubāze mums ir tāda haltūra, tāpēc ir neviena viens, kas jums pats.
Skaidrs.
Tā ir tā situācija, tāpēc mēs beigās teicām, labi, uz pusē mēs no kursa ātri paņem. Bet tā, priekšmeti ir pavisam kaut kas cits. Mans lauciņš ir mākslīgā intelekta. Aģenta, daudzaģentu sistēmas, kā būvēt, izkliedētas intelektuālas sistēmas un tā līdzīgās skalā. Tas ir mani.
Sakiet, mums vai ir iespēja vispār atnākt uz konsultācijām personu?
Jā.
Nopratties tā.
Praktiski jebkurā dienā mēs varam piedāvāt, tikai iepriekš uzrakstīt vēstus un saskaņot māju.
Vispār, kādas ir priekšzināšanas nepieciešams nākamā šo kursu, jo man personīgi tas ļoti intensīvs liekas un
Viņiem smagi interesējums, jā. Bet tādos rāmjos mums ir, lai kurs sākā 10. 28. un man pats ieskrīt. Nu tad mēģinām kaut kā sabalansēt. Vai jums būtu kā viss vajadzīgās priekšzinājums nākamam kursam, un to vajadzētu būt izpildām. Viņš ir ļoti
ļoti.
nenoliedami.
Es 2 vai 3 dienas lasīju to materiālu no pirmās lekcijas un tikai tā kaut ko jau saprast. Principā problēmas ir man personīgi ar laboratorijas darbu.
Kurā dienā mēs atradīsim kādu laiku, jūs varētu?
Varbūt uzreiz par rītdienu varētu sanākt.
Tur ir nedaudz paņemt. Rītdien man ir pašvārdu dienas, bet es varu jau arī.
Bet
Tā
tu
paņem
jāpēc
rīt.
cikos.
Jebkurā laikā, rītdien, jebkurā laikā.
Rītdien man praktiski saplānot, es varu tad kaut
Es noteikti negribētu ātrāk par 10 pārējais sākt un vienā un pirmsākt.
Nē, nu, līdz, vienīgais ne vakarā, līdz, nu, 10. man laiks līdz 5:30.
Tad varbūt 10. rīt no rīta es atnākšu 10. jā, un piezvanīšu arī jums, lai atrastu.
Tā jautājums, jūs nāksiet savu datoru?
Jā,
Savu
datoru, visi materiāliem, visu. Un vēl tas praktisks jautājums. Kā no virtuālās mašīnas to informāciju dabūt ārā, lai, teiksim, atskatīt sagatavot?
Tur ekonomiski modīgi.
paņemiet tā virtuālajā mašīnā, tur ir install virtual machine addition. Viņš uzinstalēs papildus pakotnīt, un mums varēsiet vienkārši kontrols, Ctrl+V visu kopēt. Nav problēma. Tā viena mašīna tikai labais vēlos, un tas vēl mēs varam manīt vēst. Un paši apakšā, ja šeit installēs. Tikai saglabājies tā darbu, un es neskatīšu no virtuālā mašīna, jā? Ļoti labi.
Varam iedot, par tā, ka diezgan
Paņēmu novērtēt uz datubāzi par mašīnām, īpašniekiem,
Ceturtdien es esmu, izņemot to, kā no
reģistrācijas maksu, tas tehniskais informācija, un ar vidām saitēm un ir jāatrast viena šeit rakstīts, ka es tā saprotu, ka viss mārs jābūt viena, jā, saiti,
pacienti, tad vēl varbūt kaut kādas slimu kaut kādas, nezinu, vietas kaut kādas,
ir, jā, kādam īpašniekam varbūt vairākas mašīnas. Jā. Pārējais saprast, tas varbūt primary key un foreign key, tā arī līdz galvenais.
Un foreign key mums tā, katrai mašīnai jums būs īpašnieks, ne?
Jā.
Un tad jums kaut kur pie šiem datiem jāpie Jā, šeit kā vēl viena. Ko tad jūs rakstīs priekšā šo te
Padomā,
mērķi?
vispār, kas viss
Tātad, piemēram, šim te BMW jūs būs īpašnieks Jānis. Ja tā ir, tad pirmā verificēsim. Un tad jūs referējat, ka šis te eksistē forest key.
uzreiz, un gadījumā, ka viss šis labāks spēcīgs struktūra uzreiz pirms sāk pildīt. Nu, tas būtu vienkārši. Man nesanās beigās tā
Jā.
Katrai mašīnai, kad mēs varam principā katru mašīnu identificēt pēc tā unikālā
Tikai es gribētu, lai viens šo tīzēns, kā to es domāju, cik kā jūs parādījos Ja jūs šeit visu ielaikat, tad šāsīt nav šeit astāja ciparā. Tā, šis te rodēs salējies, nospējot finišu, viņam vajag prasīt restartēt. Tad restartēsies, un pēc tam būs iespējams gan kopēt, gan vairs nevar savu jāsaka, vai varēsiet vienkārši ar kādu programmu ar vēl. Es jūs
Skatos, ka tiešām ir kāds ir nosaucis, ja? Kā valdi?
Nu, ja tā ir ērtāk, tad labs. Es labu?
Nē, mums ieslēgties tam.
Es droši vien to...
Gan jau Lots man atgādinās. Uz Mac ir iespējams
Microsoft Virtual PC nav iespējams, viņam nav Macam versija, bet Oracle VirtualBox iet.
VirtualBox, ja.
Man liekas, ka tāds bija tas nosaukums. Jā, man liekas, ka bija mums viens gadījums ar Macu, bet mēs viņu uz viņu palaidām jau, tā ka it kā vajadzētu būt.
Jūs skatāt, šis Microsoft Virtual PC, viņš ir Macam, bet tur kaut kāda kosmiska nav.
vēl nebija.
Es vienkārši meklēju, tā kā, bet beigās tad paņēmu māsu datoru, domā, sākā intensīvi pieķerēšanas.
Nē, man liekas, ka es tūņās parādīšu, kā to var izdarīt. Viņš gan pirmoreiz startējoties izmet kaudzi ar erroriem tas Windows, tā virtuālās mašīnas, bet viņš pēc tam aiziet vismaz.
Jā.
Viņš ir kā pārliek driverus, jo viņš ir kā atrod, ka viņam ir citi dzelži. Tas Macs parādās kā citādāks bišķi nekā Windows, uz kura viņš ir likts. Nu, kāpēc viņš man nepāradresējas? Nu, labi, rakstīsim vēlreiz. Vēl jau ir tāds VMware player, bet ar to es neesmu mēģinājis, vai tas konkrētais cietais disks ir nolasāms ar viņu. Bet šis te VirtualBox esmu pamēģinājis. Viss strādā. VirtualBox.org. Downloads for OS X hosts, ja? Nu, šitais te būs īstais, uzinstalējiet, un vajadzētu strādāt.
Tas princips tāds uzinstalējuši no virtuālo
Mašīnu, jā, tad lejupielādējiet to cietā diska failu.
Un tas norāda, ka virtuālajā mašīnā, nu arī to...
Jā, jūs tāpat veidojat jaunu, jā, veidojat pēc tam, kad šis te ir uzinstalēts, disks lejupielādēts, tad jūs atveriet vaļā, pasakiet, ka jūs veidojat jaunu virtuālo mašīnu.
Jā.
Ar esošu cieto disku.
Jā, un es norādu šo vienādu četros, jā. To es izdarīju. Un kur varēja viņu tā kā kā uzinstалēt kaut kādu upgrade viņam, ka var tur staigāt pa kādiem ekrāniem.
O, to es vairs uz Maca neesmu mēģinājis, bet jāskatās. Viņām ir tanī logā, kas būs virtuālai mašīnai, vismaz Virtual PC, ir Actions Install Virtual Machine Editions. VirtualBoxam es nezinu.
Pagad, kurā vietā? Tā kā, es atceru virtuāli.
Ir vaļā virtuāla mašīna.
Tur uz ekrāna bija tas SQL.
Jā, šitās te augšā. Bet man liekas, ka VirtualBox izsīsies citādāk. Es tagad no galvas vairs viņam nepatīšu. Es kāds pāris gadus viņās redzējis tās
Es šodien bija laiks tas uzinstalēt. Es vienkārši skatījos uzreiz neatradu, kur ir.
Viņš ir augšā, tā jā. Labi, čau. Droši.
Paldies.
Tas var būt 10, jā, kas uzmanīšanas. Taču bija.
Slaidos bija. Bija viss pareizi. Tā principā jums vajag rakstīt e-pastu visticamāk nākamā dienā. Pašā sliktākā gadījumā aiznākamā dienā mēs atradīsim laika konsultācijas.
Bet tiešām man ir tāda zīme.
Man tu gribi pārbaudīt lapojumus, detaļus.
Es negribu pārbaudīt.
Tu gribi citādāku?
Kā pārbaudīt?
Marija bija ļoti priecīga parakstot arī lapu. Neskaitot tos, kas neskanīja.
Neskaitot tos, kas nesekmīgi, labs atzīts problēmas. Kā tu tā piekāsi?
Tad ir 1, 2, 3, 4, 5, 7, 8, 9, 10 un 1.
Praktiski vai nokārto 10, vai nenokārto.
Jā. Šitām divām vēl jāiet zīmēt.
Okay, es apolūdzu kā piekās. Jā, es speciāli uzliku viņu, lai neaizmirst. Okay, so now we'll start the last lecture of the course. Till now we have analyzed relational databases. But as you will be introduced in the next course with different technologies that are also based on object and relational object databases, then I will show you the basics of this technology. It's a bit different of the relational, of the concept of relations, because not only the table can contain not only simple columns, but something also else, connected with objects. But as I said, you will need it in the next course, so I'll give the very, very basic. The topic is very big, so also the basics will be quite big, and probably there will be a full lecture till the 9 o'clock. So the outline of the lecture, I'll start with comparison of object-oriented programming and object-relational databases. Come in and sit down. I just started to introduce the topic, nothing more. So, that will be the first part, the first very introductory part, and then I'll move to the implementation of relational object databases or object relational databases. They are named both ways in the Oracle. The particular implementation, and tell you about things, how can we use objects inside the databases. And these things are grouped in some similar topics. These are the ways that we can apply the objects in the databases. We can use them in tables, in columns. We can create object collections, and the last thing will be views, object-oriented views. And the very last thing, it will be one of the main topics of object orientation, how we can use inheritance to optimize our work, not to have to do the same work twice. And we can use this inheritance to copy things from one type of object to another one. So about object-oriented programming. I don't know how familiar you are with programming, so I'll start with very basic concepts now. And nowadays almost all software is developed using this object-oriented approach. Why it is so? Initially the software was developed using assemblers, machine codes, and on this level. Of course, very, very low level. Then the industry has moved towards some functional programming and other things. But all these programming techniques used previously was functional centered. The central concept was function. Function, procedure, or something like that. The program code was central. And the data were put where we needed in the program. But it appeared that it is more useful to use the central concept. The data should be used as a central concept. And the smallest unit should be created according to data. And the functions, methods, and these things should be added to the data. And that's the main idea of the object-oriented programming, and as a name states, the main concept is the concept of the object. You can read also a bit longer introduction in the material. I'll finish translating maybe tomorrow, maybe the day after tomorrow. And what is an object? Why it is so rational and why it is so good? These two things are the main ones. The first thing is that it denotes the unity of components. If we have something that we want to be processed as a whole thing consisting of several components, in the object-oriented approach we can do it. For example, if we have an address consisting of street, house number, apartment number, and so on, we can define that only the whole object consisting of the street, the house number, and the apartment number has a meaning. For example, if I'll say I'm living in the apartment number 61, you won't be able to find where I'm living. You need all these components. And the second thing is that we can keep the data and the methods or the functions processing the data together. We can logically separate the data and the methods of the same topic in the same unit. We don't have to create several functions for the same data doing different things with this data. We can group these in the same object and in the same unit. The central component is data. Data, object, and class are the central names. What is class? The class is created for each entity that is processed in the system. For example, if we process student data, then these data are put in the class, for example, named student. And the class consists attributes and methods that are processing students' data. And all of these things are specified during the class definition. We define the class, how the student data will be, and then use this data. Actually, class should be considered as somewhat like a template, where we'll put information about certain students. For example, it can be considered as such a thing. We have an identifier, which is the class name. For example, it's a student, and then we have a table of attributes. We can visualize it as a table. It has nothing more common with the word table. For example, the attributes are name, surname, personal ID, student ID, academic group. And each student will be described using exactly these things. And also methods that can be, for example, for retrieving all the data, and for example, for changing group. Of course, we can add a lot of other methods if we need. And the next thing is object that is a specific instance of some class. What does it mean, specific instance? If we have a class student, then an instance could be student John. A specific student would be an instance of the class student. And what does the object contain? It contains its identifier, which can be just an address in the memory, and its attributes and their values. If the class has only specified what attributes the class has, then each instance has the values of these attributes. And the last thing is, last two things are connected with the methods. And we can say the behavior of the class, what the class is capable to do. And we can consider it to be as an implementation view. What can be done inside of this class? And the last thing is the so-called public interface of the class, which is so-called user view. How can the class be viewed, or its instance is viewed from the outside? How can we access the data or this module? And if you look at the example of an object, here the identifier could be student, and here appears its value. Name Jan, surname college, and so on. And the methods are the same as in the class. And for example, this method could be used to change students' academic group. Probably the parameter would be the new number of the group. Basic three things, or basic three concepts of object-oriented programming are the following. The first thing is so-called abstraction. And what does it mean? The object inside it can be very complex. Of course, the example of the student was quite simple, but we can have objects that have many properties, many methods, and so on. For example, we can consider modern car as an object. It has engine inside, computer inside, and so on. It's complex inside it. But to drive it, we don't need to know everything that's inside it. We don't have to know how the engine works, how the computer is programmed, and so on. We have this public interface, which is a steering wheel, gearbox, and so on. So, we use only the things that are available to the driver. The same is with the object. We use only some things to manipulate the complex unit or this object. Actually, we can also formulate it that it makes this objects or similar or something like that. The second thing is encapsulation, and it is that we can join together object data and methods, and only part of them will be available outside. Many parts will be private of the object and available only for other parts of the same object. And the last thing I already mentioned is inheritance, that allows some class, or it will be named a subclass, to reuse attributes and methods from other classes without the need to redefine them. For example, if we have a class, for example, person, and we have in this class attributes, name, surname, personal ID, and so on. And we want to create a class student that will have the same attributes, and added some more. Student group, average grade, and so on. Then we can take all attributes of the class person and add some additional attributes. We don't have to recreate these attributes that we already have. These are three main concepts of the object-oriented programming. And the question is, if the programming is done using these objects, how to store them in the database? And the answer I'll probably try to give in the next 1.5 hours. And the title of the topic is the following. And why do we need these object relational databases? Why can't we just store objects in relational tables? Yes, we can, but it's not as effective as it could be if we use these object relational databases. So, the relational databases allow us to store separate units, separate attributes. For example, if the student has these attributes name, surname, and personal ID, then we can store name in one column, surname in the second column, and so on. This approach is used almost always if we use together objects and relational databases. It is very popular, but it's a very limited approach. First of all, we can't add methods to the data stored in the database. If we decompose object into the attributes, we can't store methods together with objects. Moreover, if some field is already another object, for example, person has an attribute address that on its own consists of street, house, and apartment, then we can't store this attribute as a whole in the column of the relational database. We have to create another table and put these attributes there. So the problem is we are decomposing the object to a very low level, till the very basic component. And that's not the thing we want to do, because we have to create very big structures, very big relational structures to store one small object, one small object of the personal identity. That's why this idea of object relational databases has appeared. Some advantages, they're actually derived from the disadvantages of relational databases. We can encapsulate together operations with data. We can store the methods or the functions that are in the object, also in the database. Objects are efficient. We can operate with more than one related object. We can operate with linked objects, and so on. Again, an example with person and his or her addresses. And probably the biggest one advantage is that objects can represent this part of a relationship. That we can, that one object can contain other objects as its parts. And here again is this example about address, that they are natural because both in programming and in our everyday life we have such things that only together make some meaning. If we have only some parts of the address, for example, if we have a street and an apartment number and we don't have a house number, then we can't find where the address is. And if we store these things in a relational table, we cannot say that only all columns together make sense. Moving to the implementation, or starting to answer the question, but how can we do it in Oracle? There is some factual information that Oracle started to support object relational databases from the 8th version. Current version is 11 or already the 12th is official version. The PL/SQL language is used to define objects. The PL/SQL language was presented just a few hours earlier to you. And I defined the concept of class in the object-oriented approach. In the approach of Oracle, this concept is named object type. But otherwise, besides the name, it's almost the same as the class. But only in these databases, it is named object type. Objects have descriptions in the definitions. They are described what do they contain, what functions, what attributes, and so on. And they have instances, or as called in Oracle, objects. We have object types and objects. Instance contains very similar things as object did. It contains unique object identifier, which ensures that all entities or all objects included in the database are uniquely identified. Its state, or the values contained by the object, actually these are attribute values. Again, an example, if the attribute is name, then the state is Jan's. Behavior, these are possible actions or methods, that meaning programs that are stored together with the data. And the last thing is the name. Probably that can be a name of the variable. And it is used to give some associations. To give some associations to the programmer, to another programmer which will use this code. So the good style is to use meaningful names. I'll probably do bad today with this, but I have another purpose of it. So, what is this object type? It is almost the same as C++ or Java class. If you know something about these things, then it will be much easier for you to understand. So the object relational, in the object relational database, each object is an instance of some object type. We create a type, and then we can create its instances. And to create object, we need to define two parts. It is a specification or definition, which defines all attributes. So attributes are defined explicitly in the specification part, and also there's the definitions of methods or a method interfaces. This specification part actually shows the interface to the outside. How can we use the object, the attributes and the methods inside in this object. And the body contains the program code. How these methods will be executed is defined outside. That of course differs from almost any other programming language, but that's the approach Oracle has chosen. And that's the way it is implemented. So Oracle's object type is again very similar with a class. It contains one or more attributes that define the structure, or the state will be defined by these attributes. As you can see here, one or more, so object must contain at least one attribute. But it can contain none or some methods. So there will be objects that have no methods, that have only the state, the data in it, and no methods. This Oracle object type, or these classes that we create, can be further used as any other type in the Oracle. When you create this object type, you can then use it in the same way as you use, for example, type number. And there are some examples. How can you use them? For example, that object type can be used as a type of the column data. It can be used as a variable in PLSQL language, and so on. And as I said, the instances are called objects, and when you have defined the instance, then values can be assigned to its attributes. If you have this instance, then we can work with its attributes and with the methods. So this object relational model can be considered as an extension of the relational model. It actually supports all operations of the relational database. For example, if you use objects in your tables, you can still use queries select from where. These structures remain the same. And actually these SQL and programming, in particular PLSQL interfaces, have been extended to support these objects. And you will see how it will be done. The idea is that you can store objects, but still be able to do all things that you can do in a relational database. So you can get this benefit from directly storing objects, but you do not lose the operations that you can do with relational tables. Some things that are extended to provide this object orientation in the relational databases are the following: that we have this inheritance, that we can create a type based on another type, taking its attributes and methods, type evolutions, that you can change your types during the time, add new attributes, and so on. SQL language is extended to cope with objects, object views, that you can create object-oriented views using relational tables, and so on. I'll not go through all these extensions. You can read about them in materials. So, going to more practical things, more things that are more connected with your practical labs, is how can we create these types. If you remember how can we create a table, then the create table initially is very similar. Create table, create type name as object. This as object specifies that this type will be object type. If we start reading create table name, this will be the same. Attribute, its type, the same as for the table, and so on. The only thing that we can add, the method interfaces here. I'll not comment on them now. And of course, the type body will differ from the table. There will be particular definitions of the functions and procedures that are included in the object. Actually, you can think about the previous lecture. You were told about functions and procedures. There, you were told about independent ones that are functionally oriented. The main part was a function and a procedure. This approach allows you to add these functions and procedures to the data, to the object. And this is defined create or replace type body. Of course, you can add here also or replace. It is some type. This type name would be the same. And you can add also both here and here the share name or the user name. As you all will be working with the user system, you can write here either system or nothing. It will be the same. Is or as one of these keywords. Actually, does not matter which one is used. And then to specify all functions and procedures. As you can see, there are different keywords, different types of methods. I'll explain them one by one. And this definition means that it is full text of the function with declare, begin, end, and so on. There is an example. How can we define a very, very simple object? Create or replace type object employee as object. ID, number, name, vector, and so on. And last thing, we are defining also one method, which is member procedure print employee. That will print the employee's data just by printing it on the screen using the constructions my colleague explained as one of the last things in the previous lecture. And the type body of this type will be create or replace type body, the same name as previously used. You can see it was object employee here, and it is object employee also here. As member procedure, print employee is begin, and here is the end of the procedure, and here is the end of the type body. If there would be more procedures, more functions, the second one would be started here. So this one ends here, and the whole body ends here. So if there would be another function or procedure, it would be added here. And this particular procedure is very simple. It just puts on the screen employee's ID number equals to the ID. And these things, but probably you could wonder where this variable ID comes. That's one of the ideas of the object orientation. These member functions, member procedures, have access to all attributes. We can call this method of one instance, and all attributes of this instance will be available for us as variables by name. We can change them, we can use them as now to put on the screen, and so on. We can put one by one attributes on the screen, then put new line, and that's what we want to do in this example. I hope it is clear what this procedure does. At least it should be. Put these on the screen. It will be printed employee ID number, colon, space, 7, for example. If the particular employee's number will be 7. The same with name John, for example. Surname Smith, and so on. And then move the cursor to the new line to smoothly format the result. So far we have created an object type. How can we create an instance? We have to do it in some declare part of some anonymous block, another function, another procedure, and so on. we can declare a variable type, and then, for example, we can use student instance will be of type student. But if we just define a variable of this type, then there will be one problem. And according to the syntax of the PLSQL language, the object will be so-called null object. And actually we can illustrate it like this. If the object is null, it has some fields. For example, if it was student, and its fields will be name, surname, and so on. And there is nothing in this field. Not even the null value. Actually, these fields, there is no memory allocated to these fields, if the object is null. And there is also a difference between such a null object and an object whose all attributes are null. Because if the full object is null, we cannot address these attributes at all. That will be so-called runtime error if we try to access such a name. But if this object contains all attributes with null values, and probably there are other attributes also be null, then we can access this field and get the value null. Then this object is not null at all. Probably we can illustrate it like this. The null object is blank space, and we cannot find where the name is, and if the attributes are nulls, then these are blank spaces here. And we can know that this is name, and it is blank or null. And to start operating with such a null object, we have to initialize them. And it is done by the so-called constructor function. Again, the same thing as in any object-oriented language. To initialize the variable, we have to use these constructors. For example, the student instance could be initialized by the function student. The name of the constructor function is the same as the object type, and it has the same parameters by name, number, and order, and type. For example, if the first parameter is ID, the second parameter is name, then also object should have the same parameter. And we give this name of the type or the name of the constructor, which is the same, all these values, and two things will be done. The first thing is the new object will be created, and the second thing, these values will be assigned to its attributes. And the constructor function is defined by the system. You don't have to define. And afterwards, you can access its attributes. For example, you can change the form of the object. Now moving to the things, how can we store these objects and how can we use them in practical examples. So the first thing is so-called object tables. We can compare them to the relational tables, and there are two differences. Instead of rows, we have the objects here. Each row is one object. Previously we had some columns in the table. Now the whole row is an object. But now, instead of columns, we have the attributes of the object. So we can draw very similar picture to the traditional relational table. If the whole row is an object. One of the big differences is that each of these values also can be objects containing different values. And we'll look at such options a bit later. So, how can we create such an object tables? We create type. For example, very simple type. Person, create type person as object, name, surname, phone, and then we just create table persons of person. This is the name of the table, this is the name of the type. As they mean the same, I've used almost the same name, just a single case and a plural. And after creating such a table with these 4 simple lines, we can use it. There are different options how can we insert data in such a tables. We can, of course, use the insert operator. It actually will be used in all cases because that's the operator that inserts data into tables. We can use the insert operator and the constructor function. That's the first option, but there are also 2 other options, and let's look at them in detail. So, we can create an object with this constructor function. Remember, the name of the object was person, so the constructor function is named the same, person, and we have 3 attributes. The first one was name, second was surname, and third was the phone number. We create the object with this constructor and then insert it into the table, because the table now contains only 1 column, the only 1 value, the value with the type person will be inserted into the table. Another option is to use a very simple program. Take a variable of type persons, initialize it with the constructor function. The addressing by name is used in this example, but of course the addressing by order would work also. And insert into persons this variable as the only value. And the last thing is that we can do exactly the same insertion as in the relational table, but only one limitation. You cannot insert the first row like this. You have to use one of the other options for the first rows, and only then you can use this. This one, of course, is the most simple and probably already known for you from your practical work. Again, we can retrieve data in more than one way, similarly to the insertion. And we can consider this table to be containing 1 column, which is the object type, and we can consider this table to be to contain more than 1 column, which are the higher level attributes of the object. If we scroll up a bit to this picture, then we can consider that the table has only 1 column as this big rectangles, and the type is an object, and we can also consider that these are our columns. Actually, these are columns, these, and also these. In this case, we can consider this table to have 1 or 4 attributes if we retrieve data. And how can we do it? If we want to retrieve whole objects, so all data together with methods and allowing us to execute the methods of objects and so on, or to work with them in the object-oriented way, then we have to use this operator value. And we'll have the value of the object. In the previous example, the result is a relational table with one column whose type is this type of the object, this person. And the second option is that we can consider it to be a relational table whose columns are the attributes. Then we don't use this operator. And the query returns us the relational table. How does it look like? If we use this value, we use in the from part we write persons A. We give this alias to the table persons, and we take this value A. The result is the whole object. Such a parenthesis or brackets denote that this is a whole object. This is a type of the object, and these are its attributes. It is denoted like this. Of course, we can write here any selection criteria and do any other operations. And the second option that we can, for example, select a name, a surname from these persons A. And it will be retrieved as a relational table, two columns in particular. If we just select everything from persons, it will be treated as a relational table and also give us 3 columns because the type person contains 3 attributes. Also, we can change objects in exactly the same way as the values in relational tables. We can consider this table to be a relational table and, for example, update persons A, set A equals to such an object where a surname equals what. We could also set, for example, A dot surname equals something else, just changing one attribute, not the whole object. So, summarizing about object tables, that are objects that occupy the whole row of the object table. And these objects are named row objects. And we can do all the things that we can do with the relational table, we can do with object tables. No limitations at all. We can also apply all integrity constants, triggers that are supported by relational tables, also by object tables. The other option, how can we store objects, as I also already mentioned, each column can be a separate object. Both the column of the database can be an object, and also any object's attribute can be an object itself. So we can actually create something like this. We have these objects, we have this, for example, first attribute, second attribute, and third attribute. This attribute can have attributes on its own. And the hierarchy level of such part-whole relationship is unlimited. We can create that here is one attribute, second and third. Again, here can be more attributes and so on. And that's actually the idea of the object columns, that this can be either a row of the table or one particular object, and one attribute can be an object. So, the object tables is not the only one way, we can use them also like this, and such objects are named column objects or field objects, as column and field in this case are used as complete synonyms. How can we create object columns? For example, recall the previous example, we created an object person. If we have this object person, probably we would like to store its data together and add some other data to get all data that we need for an employee. Then we can create a table employee, relational table, whose first column is ID, normal or relational field. The last two also are traditional relational fields. But the second one can be field named employee, whose type is person, and all data about all personal data of the person would be included in one column. We can draw it like this. The first column is ID. Well, the last two columns are position and salary. I intentionally draw these three columns small and one big one. And here is the salary. Then, for example, here would be the ID would be 1. And if we have this person here, and it contains 3 attributes, then all 3 attributes, for example, John Smith and his phone number, something like that, would be in this cell, in this one column. And the position could be, for example, CEO, and salary 500. These are atomic values. This is an object kept together. I think you can see the difference. But we don't have 3 columns, for example, here, but we have 1 column for the whole object. Again, about how can we insert data, and it can again be done with a constructor function. We do the insertion like in the relational table. We give an ID. We give this object created by the constructor function person with name, surname, and phone number, and position and salary are going after this object. The constructor function is ended with these brackets. Again, we can retrieve data, retrieving the whole objects or separate attributes. The first example, if we just select everything from employees, the difference from the object tables is that this second level attributes won't be considered as relational columns. Such a very simple query will return the whole objects. Person with its data will be animal. And of course, all other columns will be retrieved as relational data because they are relational data. The second option, we can also retrieve only the object column. It is the same way we are retrieving the whole object. And it's also possible to retrieve only attributes of the object. They can be retrieved together with other relational data and so on. For example, we can denote this employee by A and take A employee name. The employee is a column name here. Actually, I should write it here employee because the column name was employee. That's my mistake. So we can address table which is denoted with this alias A. The next after dot comes the column name, which is employee, and then the attribute name. So the first thing is A is a table. The second thing, the employee is a column, and then the certain attribute is the third thing after these dots. First dot and the second. And of course we can add here, for example, a ID, and there will be ID and a name. We can retrieve together this number, for example, with name. There are no limitations. We can just choose this ID, name, phone, and salary, without position, without surname, without the full object, and so on. Just we have to know how to address these things, that the attribute of the second level, these ones, this name, should be addressed like this. We can also change these attributes of objects. Here is an example of it. Update employees, set a employee surname. As you can see, we're addressing it like in the select query. We'll put offset, where the ID is 101. What will be done? Where the ID is 101, in this row, the surname, if I remember correctly, was offset, will be put here. And the theoretical notion behind these things that we can address the attributes as we do is the so-called Object SQL, or in abbreviation OSQL, which allows to operate with attributes as with columns. Actually, as you can see, we do not care whether these are, for example, the higher level is the attributes of the higher level. They are attributes or columns. We can access them in the same way. And we have no limitations where to put them. We can put them in the select part, in the whether part. No limitations in these things. So, once more the reminder about the null object. It differs from the object where all attributes are null. Remember it within your labs. You cannot change your attributes, cannot call their methods, and in fact the whole object is empty or non-existent. When you are inserting data, any column object may be null, any row type object cannot be null. And I think it makes sense. If you have a table like this, and for example, this one is the object column, then you can have a meaningful record by writing something here and leaving it blank. But if your only column is this object, it's here, and if you're leaving it blank, then you don't have the whole record, and the empty thing is not meaningful, so it's not allowed. So far about objects, attributes, how to store them, and the second part of the object is its methods. How to process these data. What can we store together with data? As previously stated, methods can be functions and procedures. The very similar things to the last lecture. The only difference that these ones are not independently stored, but together with methods and together with data or objects, and operating with attributes of these objects. Methods are declared in the type definition, and their behavior define what can be done within this object. And the most principal usage of the method, or the most principal goal of the method, is to access object attribute. Because if the method has nothing to do with objects, data or attributes, then the question is, why should we put this method inside the object, not independently, if it does not do anything with this data? And to execute these operations, something outside the object, here it's named application, will call the corresponding method from the corresponding object to do something with this object. Now we'll return to the types of methods. As I said, there were a lot of keywords and I did not explain any of them. Now I'll do it. But first of all, I would like to mention that the methods can be written in very different languages. It can be done in this PL/SQL language, which is the only language that will be used to store methods in the database. But these methods can be also written in any other languages and stored outside the database. During this course, we'll use only the first option. So the second one, to store the methods outside the database, will be for you as a theoretical knowledge that you can do it and nothing more. So the main types of methods are so-called member methods, which is the main group of methods, static methods, map and order methods, you will see why I group them together, and the last thing, the constructor methods that we already mentioned. The first thing about methods is the purity levels. I won't go into details, but the only remark is the following, that you can use functions inside the SQL statements. In the SQL queries, insert, select, and so on, you can use these functions. But to do it, these functions have to follow strict requirements. You are not allowed to write a function that during the select statement changes the database, for example. No user will understand that it is like this. And as you understand, it's dangerous. And so you have to declare that your function does not do anything and the compiler won't allow it to do it then. And if you specify this first level, which is write no database state, then your function can be used in the select statement. And there is a syntax how can it be specified, what is allowed for function, what is not. These things, there are a lot of things that can be specified what is allowed. I won't go into details now, because there are some also a bit complex things. If you are really interested, the details are in the materials. Only remember, if you want to call the functions SQL, you have to use this one. The example of some type, which is a type of student, we can define a lot of attributes. We can then define lots of functions, for example, map member function sort order. I'll tell what the map function is in a moment. Member function average grade, which calculates student's average grade. We want to allow it to do some things. We will specify these purity levels. Member procedure change surname again, the same with purity levels and so on. That's the way how we define this in the type definition. It's not the type body definition. There are two different things. So far the type definition. And the type body definition, I remember. For now, I just remind you that such a thing exists. So, one by one types of methods. member methods are those who use and operate with objects data. All these will be member methods that are built to operate with data, to retrieve some data, to change some data, to calculate some values from objects data, and so on. And usually their goal is to implement access to these instances. And to do it, to access these, objects attributes, there is a parameter self. So self means the instance whose method is involved. Now let's get into the details about one very simple example. For example, we can have a student, all data about student, all personal data about student, and 3 grades. Grade in math, grade in Latvian language, grade in physics, and average grade. And we'll have the member procedure that will calculate this average grade. It is member procedure and its name. And that's it what we have to state in the creation of the type. All other things will be in the type body. If we had some parameters, they would be stated here also. But if we do not have them, then nothing else. And the type body will contain the only method we have. Create or replace type body. Student has member procedure, average grade. And average grade should add together 3 grades and divide by 3. So the self average grade is equal self grade math plus self grade Latvian, self grade physics divided by 3. And that's it what the procedure has to do. And how can we, for example, calculate average grade of one student? We can write a very, very simple procedure, and it is declare variable 1 type student and begin. We select one student whose ID is 1. We select it as an object. It will be for us in this variable. And this variable allows us to call this procedure. The procedure is member procedure is called by giving the object using this dot notation and the name of the method. The same will be for functions, but only the function will return some value. It will be stored in some other variable. And afterwards, when we change this one, we delete the student from the table and input the new one whose grade already is calculated. And afterwards, previously we put in only students, their names, surnames, gender, and marks, and now average value. This first student will have now this value calculated. That's a very simple example, of course. It will not be the best way to calculate these average grades because we have to call these procedures. Explicitly call them for each student. We'll see further how can we calculate them by using functions, and we'll not have them to have this extra field to explicitly calculate and so on. But now a few remarks about calling member methods. About parameter types, by default parameters for member functions, which return value by their name, are in. So if you have a name that returns, then by default the parameter is only in. For procedures, the parameters are in-out by default. And as I said, this is the way how can you call the method, the member method, using this object. Called method will be called, and then the name of the method. And of course, the object is on the left side as the biggest one thing, and its part is on the right side as the smallest thing. It always goes from the biggest one, if we have one very big object, and then smaller ones will write the biggest one on the left side, and the very, very smallest one on the very, very right side. And the next two types are also member methods, but they are for the specific purpose. And the idea is the following. If we have some scalar types, for example numbers, we know how to order them. For example, if I would ask you to order some numbers, 9, 5, 12, and so on, from the biggest to the smallest, I think you will give me answer immediately. But now, if we look outside the window, there are 5 cars. If I asked for you to order them somehow, I think there would not be the one and only one correct answer. You could order them by different attributes, different things, and so on. Which ones you like, and so on. So, also, if we ask the machine to order cars, objects that denote our cars, the machine does not know how to order. It does not know our preferences and so on. Probably you would like to order them by engine, you by, I don't know, by weight and so on. And the idea is that to be able to order or to compare objects, we need to specify how it's done. And it is done by the following two types of methods. The map methods and the order methods. And each object can define only one of these methods, because both of them are with the same purpose. So, about map methods. Map methods compares object based on some of its attributes. We can compare some attributes and give an answer which object is mapped to what value. This method will return the number or some other value, for example date, denoting how good this object is. For example, one car would result in the result 100, the second car will result in 120, the third maybe minus 200. That's nothing to do with their value or something like that. Any other variables can be used. And thus this method can be used to order a lot of any number of objects. If it maps the object into the number, then we can order them by numbers. And it does not matter if there are 2 objects we're comparing or 7. If we get a scalar value or a number, then we can put along this scale. The keyword map is used to order to define such a method, and the method is automatically executed when we execute some comparison. For example, this one object would be a black car, this one object would be a red car, and if this comparison is done, then the corresponding map method would be executed. And there is an example. Again, return to the student with his or her 3 grades. As you can see, we no longer have this average grade, but we want to order students by their average grades. And then we define the map member function, which is named student evaluation, which will return the real number, which is student's average grade. And this body will be very simple, create or replace type body, student, as map member function. Again, this will be the only one function. Student evaluation, it will return the real value. The calculation, of course, will be the same, only this value won't be given to the average grade attribute, but it will be returned as a result of the function. So grade, mass, so grade, Latvian, these are added together, divided by 3. And that's all we need to do. After we have defined such a function, we can order students in the following way. We can select values from students. Actually, we can select any field, for example, only surnames. And we can order them by value A. Value A is the object column, or is the object row, by the value of the whole row, which will be computed by Oracle as the average grade. Of course, we can order students ascending or descending. Default is ascending, so they are ordered from the worst to the best. As you can see, probably quickly, as you can quickly calculate, the first one is the worst and the last one is the best. So such methods allow us to order. Very similar, and not only to order, but also to compare objects. Ordering is based on comparison, that's why we can also order. And the next thing is the order methods, which are very, very similar to the map methods. The only thing is that these methods can be used to compare only two objects. Because the map methods give us a real number, or the scalar value as a result, but the order method just says which of one of two objects is greater. To do this comparison, this method should be called by giving a parameter, or is called by giving a parameter of the same type, the second object. We have our object and we compare it to the parameter. And it is done in a very simple way. We return -1 if the value of the object given as parameter is greater than our value, 1 if it is smaller, and 0 if the objects are equal. It is allowed also to give any negative value here, any positive value here. The ones are just the simplest ones values to give. Again, an example, the way how to create this function. Instead of map, we will give here order, and we'll have one attribute which will be, of course, another object to compare to. And there should be an example of order method. We'll compare clients by their ID numbers. For example, we can give ID numbers in the order clients appeared, and we want to compare which client is older for us, for the longer time, our client. Then we can create an order member function which compares this client to another client, and the method its own will be the following. If our ID is smaller than this object, which is given as parameter, the variable c, its ID is then will return -1, else if it is greater than the other client, then we'll return 1, and in the last case, if it's not smaller, not greater than it's equal, we can return 0. These are the ideas of map and order methods, which are automatically executed when you compare objects. Of course, if such methods are defined. Another concept is a static method. The only thing I'll say is that it is executed with types instead of instances. It's again the same as in other programming languages, and it usually does the operations that are common to the whole type. For example, some initialization, something like that. And then we can call it by type name and method instead of instance name. And these also are just for information for you. I will not ask them in any labs or something like that. The constructor methods, I think I already explained enough about them. They create a new object and assign values to its attribute. And the returned value, which can be assigned to any variable, is a new object. What does it mean? Assign, I'll give a very brief and simple example. So we have some variable, for example, 1, and we can assign a value to it, and the constructor will be, for example, we'll have, for example, type, which is abbreviated from the word object like this, and some parameters. For example, the first value will be a, the second value will be 1. Then this function will create a corresponding object with this name, 3 letters, and it should contain 2 attributes, whose values will be these ones. Of course, we should previously define this variable. And we can use this function, of course, not only in PLSQL, as I gave you an example, but the slides were full with examples that show you how to use them, for example, in SQL statements. One more concept I wanted to introduce you briefly is object references. And the idea is that you can refer objects not only storing the full object, but also giving just where the object is stored. And it allows you to create relationships between objects, similarly that in similar way how you did it in the relational databases. For example, any attribute of an object, any element actually can be defined as a reference to another object. It actually implements such a relationship as one-to-many. Some limitations that refs can be defined only for row objects. If the object is somewhere in the column, it's a column object, and then you cannot have a reference to it. And it is connected with such a thing that a row object has a unique identifier which is used to give these references to the objects. Example, for example, if we want to have some table, for example, ID, name, and others. So I want, for example, John, and if we want to store the whole address here, we have, till now we had only one option to write an object in here. The object would contain street, house number, and so on. But then another option is to store addresses somewhere else, to put addresses here. The address would be be as a row type object here. And write here a reference, which is in Oracle named ref. And this reference here, it contains some unique identifier which uniquely identifies this object. And it allows some flexibility. For example, this ref can be the same as this one, and also refer to the same object. If we store the address here, in case two people are living in the same address, which of course is a real life situation, then we could store the address only once and both refs would refer to the same address. As you remember, this is a concept for the relationship one-to-many. For each person, there is only one address. For each address, there could be more than one person living in it. If we put the addresses here, then it would not be possible to do it. How to write it in Oracle? We can create address as an object, and this last field would be defined as ref address. And we'll need this table separately defined, because now we have two tables. And the last thing that we can define the so-called scope of the reference. What does it mean? That means that this reference can be only connected to this table. We cannot, for example, give a reference to, I don't know, table cars. We can't put a car as an address for a person, for example. How can we do the insertion? For example, we can do it in the following way. We can insert into addresses some value, and for person insert for now the empty address or the null value. And then find this address in the address table. It is done in a very simple way. Of course, it would not be correct if we had more addresses here by the number, by the host number actually, and then we update this record of persons by putting this address reference, which is the variable of type ref, and where we selected the reference into it and put it here. And as a result, if we select everything from persons, we get something like this. Is it readable for you? Not really. So if we are using references, we need some mechanisms how to use this one machine readable thing to get the object we need. And it is done with the so-called deref operator. And it solves the problem that these references are only computer readable. And the accessing object through the reference is named also dereferencing. And it looks like this. We can use deref from this field a address and get the object of that. After we have retrieved this object, we can again use this dot notation and work with all attributes of this object. The last big topic is collections. What does it mean? As Ilse already explained, what was worry? One of the types of collections is this one. So it allows us to store one-to-many relationship in one table. In the relational database, one-to-many was created in two tables. This object thing allows us to store such a relationship in one table. And it is done in the following way. I'll give a brief illustration again. We have one table. Some columns. For example, ID again, name. And for example, projects where the person is working. Name John. And these collections allow us to do the following thing. If we use the relational table, we would add another table projects, which would have John's identifier and the project that John would have. But now we can, of course, it's just schematically shown, add here some collection of objects, or even a table, that has the whole information about John's projects. For example, project 1, project 2, project 3, and some names of the project. That's the idea of collections. As I said, there are two types of collections. Actually, I've illustrated the idea of nested table, but varying array is very, very similar. I'll show you both of these things. Varying array, as it is abbreviated as vary, it is an ordered set of elements. There are some elements that have defined order. Each element can be uniquely identified, and you can know its position in the array, you can access it by this position, and so on. I think I'll skip how to create these things and move to the nested tables and show you the difference. So about nested tables, the difference is that it is unlimited and unsorted. If the vary was sorted, indexed, and limited, the nested table is unlimited and unsorted. And still all elements have the same data type. You don't have to define the maximal number of elements, but you can use all the benefits that querying gives you. You can select data, insert data, update data as in a relational table. So you can insert either an array here, which contains some number of elements ordered, or you can insert a table here, which can be operated by SQL language. And these elements of the nested table will be physically stored somewhere else. And the links to this place that I named somewhere else will be created automatically. Yes, physically two tables will be used, but you as a user, or in this case a programmer, won't have to specify this another table and take care of storing the data in this another table. So the limitation of a nested table is that it has a single column. But you can easily cope with this limitation by defining it as an object table. As you remember, if we create a table with one column, which is an object, we can then treat it as a relational table containing more than one column. So, for example, we can create a table of persons and include the nested table addresses as the nested table. How does it? Okay, I'll tell you in details another example. For example, we can have the table containing our courses, for example, our specialty, database, information system, design, and so on. What students have these courses, for example, what groups of students, and we have some list of literature. Of course, each course can have more than one source of literature. And these cells could have some for nouns, one or some rows from the table books. For example, the course information systems, the book information systems would be added to the information and design, information systems and design courses. And for example, database course would have book databases and database technology. So more than one value would be added here. And physically they would be stored in this table. That's the idea of nested tables. There's an order what you should do to create these nested tables. Create object type, create nested table, what records are of the previously defined type, create the main table, and include this nested table in the main table definition. And then you can operate with this table, insert data, update data, delete data, and so on. That's the idea. I think I'll skip the exact creation of these tables, otherwise the evening would become very late. So few ideas how can we use these nested tables. Again, we can do the same as with object types. We can consider them. We can retrieve all data as objects and as relational databases. For example, we can, as I said, list of projects here. We can retrieve name of employees and list of projects, which is, in this case, just a list of numbers. We can retrieve them like the row of the main table with the object of the nested table. So this whole table is as a single object retrieved. The other option is to retrieve each row of this table together with the corresponding row. As you can see, the same employee now is retrieved more than once, as he had here 3 projects. That's why he has 3 rows here with corresponding projects. The idea is that despite you are storing your data like this, you can always transform them to relational structure. That's what I wanted you to tell with these things. Well, the last remark is that you can create these collections in unlimited levels. As I was drawing on the board, that you can create a hierarchy of the part-whole relationships, that we can have a big thing, a bit smaller, then again. And the same is with these collections. The type stored in each row of the nested table can be again a nested table. The same with vary and so on. And other option is that the nested table is an attribute of the objects included in the query or nested table. So these structures can be created as you need. Of course, I'll not give an example for each of these, but I think the idea could be understood. And the very last thing I want to tell you about is the so-called object views. What does it mean? I explained last week what the view is, and now what the object view is, and what the idea is. Till now we analyzed how to create a new relational object database, and how to store objects, the whole objects, into the database. But it only fits the situation when we are creating a new database. And the object views help us if we already have a relational database. We can look at it as an object relational database through these object views, which allow us to create an object-oriented abstraction based on the relational data. We can look at relational data as they are objects. So we don't have to modify the schema of the relational database, and we can use it as an object. Object view has a similar characteristics as an object table, because each row of this view is an object. So it is object table. Each object has an identifier, but this time it's not generated by the system, but it is specified by the user. And usually it is used, the primary key of the relational table is used. And how does it look like? For example, if we have a table employees with some fields, employee ID, surname, salary, position, and then we insert some values, very simple values. Works will be carpenter, and Zars will be a secretary. And how can we, if we have already such a database, how can we use it in object-oriented way? And it is done in two steps. At first, we have to create the type that will be our resulting type. If we want to create a view for the specific table, then these attributes should be the same as the columns in the table. And then, when we have created this object type, then we can create a view. And the key is here, the underlined part, that we say that this view, named employee view, will be of some object type. This type is defined here. And then this is an object view. Its unique identifier will be the primary key of the table. Actually, it was not defined as a primary key, but it should be here. Here should be stated that this is primary. And we just select a field from the table we need. We can select all fields by specifying this asterisk, or some fields as here. And as of now, we can treat this view as an object table. So a few words about type inheritance. As I said previously, it allows us to take some attributes, some methods from one type and reuse them in another type. And the idea is that if we define that one type is a subtype of another type, then it is a specialized version of its parent. For example, a student is a specific person. It has its attributes as student ID, average grade, group, university, and so on. And these attributes are some additional attributes that can be added to the parent's attributes. And of course, we can add also some additional methods. For example, that calculate the average grade. and so on. And this new type, in our case, student, would be named a subtype of a supertype. And the supertype would be a person, in our case. And the relationship among subtype and supertype is said to be inheritance. And all types connected with this relationship are named to be in the hierarchy of the types. And I'll skip probably this one and this one and only show you this picture. For example, we have some type that has only one property. It's a cloud. Or probably we can say it's a weather. And then we can add more attributes. For example, thunderstorm is an attribute of this object. Bad mood is another attribute of this weather. And we can go further in details. It's also raining in this one. There was no rain, but all these attributes that were here are also here. We cannot remove, for example, this attribute by defining subtype. It will not be a subtype anymore. Another situation can be derived from this one, because there is nothing. We can add everything we want. For example, sun and good mood. Another situation that we can add here. And this, you can also forbid this inheritance by defining whether the type is final or not final. And the final is default, so if you want to inherit something, you will have to define that the type is not final. And the inheritance then is done by this keyword under. As I said, student under person. We do not specify name, surname, and so on here, but still the type student will have these attributes. The name, surname, personal ID, and so on. But these ones will be added to this type. As for all chapters, for all topics of the course, you have some additional literature if you need it. About materials in English language, I hope I'll finish preparing them tomorrow. I didn't make them for today. I apologize for that. And do you have any questions concerning the topics of today, concerning your labs, or something like that?
When is it appropriate to come to consultation, or common times or something for all of us? When is this convenient for you?
As I said previously, my times change day by day. And so please write me an email and we'll arrange a time. Your colleague arranged time for tomorrow at 10 o'clock. So if you want, you can come tomorrow at 10 o'clock. If not, we can arrange another time.
Because it's preferable for me to come on evenings, something like that.
For me, the next 2 evenings are not available, I'm sorry. Probably on the Thursday.
This Thursday?
Yes, this Thursday. Today is Tuesday. Tomorrow definitely is not available because I have a lecture from 6 p.m. to 9 p.m.
Okay, then maybe before, let's say, before 2 o'clock, between 12 and 2 o'clock.
Between 12 and 2 o'clock. On Thursday and 12.
This actually would be great.
Thursday, 12 o'clock.
Yeah, probably. Oh, can I send you an email tomorrow if I could make it with my...
Okay, confirm on email.
Alright, okay.
Deal?
Thanks.
You're welcome. Anything else?
And so I heard the exam will be on the 26th
Yes.
in the day, daytime.
I think we arranged that it will be on the daytime.
Yeah.
Cool.
With what if
Okay.
I still don't know, but I might happen that I will be able to come today.
Then we'll have to arrange some other time for you.
No,
And some.
I'm not sure about it, but I'm not sure about it. I guess that there was but I will confirm about it next week.
Okay, then we'll arrange some other time where we will be able to come together with other students of other courses or something like that.
I see it was arranged as from 12 noon.
Yes.
Is it still okay?
If you want to change, then we can change, of course. But
I perfectly agree with that.